To TraceCloud. We are happy to announce that we have launched a new model-based system engineering product based on TraceCloud, and we are calling it Darwin. It's currently in beta, and you're welcome to use it. We expect to go live in January, so it's about a month and a half from now of 2025. But you can start using it right now. The way you get started is you press create a project and you'll see a new option for Darwin projects. These are your model-based system engineering. Your traditional requirements management projects can still be created using these two buttons at the top. But clicking on this asks you to kind of give a name and a description and a short name, and then it's going to create a project. And all Darwin projects will have an icon next to it called Darwin. So you can see these are Darwin projects. The neat thing is you can open Darwin projects in the TraceCloud view because it's still a TraceCloud project underneath, or you can open it in the Darwin view by just clicking on this here. The difference here is if we have a predefined requirements management process to support model-based systems engineering. For example, you'll see requirements, behavior, structure, and verification. In structure is where most of the action takes place. So you have system definitions and system architecture design. So system definition essentially is a place where your product team is able to define the product, basically model the product. What I mean by that is, let's say you are a drone maker or a robot maker or even your, let's say, vacuum maker, right? Or your medical device maker. You can represent your product as a model, basically a collection of components that are put together, and each of the components themselves are a collection of subcomponents. So in this example, let's say I have a concept of a simple robot. The robot itself has parts, attributes, ports, and everything. But within the parts definition hierarchy, you can see I have a concept of a complex part. And the idea here is the chassis, for example, for a robot itself comprises a battery and 3 batteries, 4 legs, and 12 wheels, and has some attributes. But the batteries themselves have certain behavior and components of their own. Same for each of the other parts. So the way this model comes along is let's start with something very simple. Let's say I want to build a drone system. What you do is when you create a package, by the way, the way you create a package is click on system definitions, create a package, give it a new name and description, and the system automatically creates something that looks like this. Initially, it's going to be empty. It just has the definitions built in, but you can go in and build the definitions. For example, for building a drone system, let me define some attributes. So one attribute I might want to define is flight time. Okay, so I can say flight time is 100 hours. Okay, how long the drone can fly. So I created an attribute definition, or initially it's in a work in progress state, but I can publish it so it can be used to build products. So now I've defined an attribute and I've published it. Similarly, I can define one more attribute here. So let's say load carrying, max load carry capacity, right? And I can say this max it can carry is 10 kilograms. So this is how you define different characteristics. Again, like I said, this is the work in progress initially, but you can publish it so it can be used by others. Similarly, I can define ports, actions, constraints, requirements. These are all definitions that I'm creating. Once I've done those definitions, actually let me kind of create a few things out here just to be on the safe side. So let's say I create a port. The port can be a data port, communication port. Okay, communication, and let's say this is Wi-Fi. Input is Wi-Fi, output is Wi-Fi, type is but all these fields are configurable. You can always go to TraceCloud configuration and add those fields to any of these requirement types. So this is what the drone is. The port is, I can publish this. So at this point in my package called drone systems, I have a few attributes that were created and published. I have a few ports. Now let me go and create parts. I can start creating parts directly at the root level, or I can create folders and subfolders. In this case, I want to create a few subfolders. So let me go and create a subfolder called, say, motors. So I'm going to create a subfolder called motors, and I am going to create one more. Give me a second. Folder management. If I want to create multiple folders, I can do, sorry, not that one, not folder permissions. I go here, folder management, create a subfolder. I can just use pound separation to create multiple ones. So for example, let's say I have my props, chassis, connectors, load, payload connectors. So I separate them by pound and I kind of copy and paste that here. So it's going to create multiple folders at a time. So I created 3 folders at a time. Okay. So now if I go here and reopen my drone system and I go to my part definitions, you can see I have these 4 folders that I created. So let me go and start creating a bunch of stuff. So in the motors subfolder, I'm going to create a part called, let's call this 6 kilowatt motor. I'm going to create a 6 kilowatt motor. That's what a part is. Now I can jump into this part. Let me go into this part by clicking on it and give it its own component parts, give it its own attributes, ports. In this case, remember I created some attribute definitions. I can say, well, I can add this and I can add this, right? If I want, I can create my additional attributes here if I wanted. For example, let's say for the motor, I wanted electrical input. So I might go to port definition and I might create a new port here, create a port, power port, and I say that this needs 1 kilowatt hour of throughput, and output is 100 newtons, and the type is electrical. So I created a port definition, and I'm going to publish this. So now I have 2 ports. Now I'm going to go back to my motor and I'm going to go to this ports. I'm going to add this port here and say, well, I'm going to add the communication port and I'm going to add the power port. So you can see it. So now let's say if I want to add additional, I can always add more duplicates. Let's say I want to add one more communication port and call this, for example, weapons communication or payload communication, which is different from navigation communication, right? All these fields are editable after you get them from the attribute definition and create an attribute here, right? So that's how I define a part. Now you can see that I have a part called 6 kilowatt motor with a bunch of attributes and ports. I can continue to add similarly the actions and states and constraints and requirements. Once I reach a certain level of maturity, I can say I'm going to publish this. So now what I have, if I go to my parts definitions, is I have one motor that's available to be used. So let me go ahead and create a few more things similar to it. So I'm going to create a propeller. So let's say I say a 4-inch prop plastic. Okay, plastic propeller. So I created a plastic propeller. I can, again, like I said, to this part itself, I can jump inside this and give it its own characteristics, right? Let's assume I've done that. I'm going to create, while I'm here, I'm going to create one more part here. Part inside the props, I'm going to say 6-inch prop, 6-inch prop, and let's make this carbon fiber. So I have created a 6-inch prop of carbon fiber. They both are WIP. So let me go and publish them so they are available to be consumed by others. Okay, now that I have the props and I have the motor, I can go ahead and create, let me create a chassis here. So I have enough stuff out here. So let me go create a chassis, create a part definition. Okay, so I'm going to create a chassis, small chassis. So I got a small chassis and I'm going to create one called large chassis. Bear with me, this whole thing will come together in a minute. So let's say I have a small chassis I published. Actually, let me go, I need to add a few more things to it. Actually, let me publish these two. So I'm going to publish this, I'm going to publish this. So far I got a chassis, 2 chassis, 1 motor, bunch of props and everything. Then I realized, you know what, from a chassis, I want to create these motor mounts to which propellers can connect. So I go here to my uh, chassis and I'm going to create um, one more part called a motor mount. Bear with me, this is going to be interesting in a minute. Motor mount. So when I create this motor mount, and I'm going to publish this. Let me add to the small chassis 4 motor mounts. So when I go to this one and I try to add parts, give me a second, I'll close all these alerts. When I try to add a part, it's going to say you cannot add because it's already published. That's because it is published, you cannot modify it. But because there are no instances created from it yet, you should be able to go here and say, I want to bring it back to WIP. And now I'm going to add some parts to it. One of the parts I'm going to add is something called a motor mount. My small drone has 4 motor mounts. And now I'm going to publish this. Okay. And whereas my large motor mount, large chassis, I'm going to give this 12 motor mounts. Again, this is published, so you can't add parts. Let me make it WIP and add a part. And I say this is going to have 12 motor mounts. Add part. So if you can think of a department in your organization um, that is responsible for chassis, their job is to continuously kind of bring up these new versions of chassis. Somebody is responsible for motors, they kind of create these motors and publish them. Somebody is responsible for props, they take care of props, and each prop has its own kind of life cycle and sub characteristics. Now, how do you use all these? Is when you come to system architecture diagram for whatever product you're building, you can come here and say, well, I am building a drone. Okay, so I am going to go here and add a part, and let me add a generic part. So you can see I have a generic part that got created here. I'll rename it. Okay, I will say small weapon carrying drone. Okay, so what I have is a small weapon carrying drone, and when I click on this now, it will refresh itself, and I have this. By itself, there is nothing in it. There are no parts, no attributes, nothing. I can choose to now start adding parts to it. I go to my published parts, and I know that in my drone system, I had created a chassis. So I'll go there and I'll say, well, I'm going to use the small chassis. And the next thing you know, the system is going to bring in everything that the small chassis had into this. Sorry, that's the wrong one. So if I close this, if I go to system architecture diagram, small weapon carrying drone, you can see I added chassis, and the small chassis came with motor mounts, and it came with 4 motor mounts because that's how it's predefined when it was published. I realized, okay, now I have 4 motor mounts, I really need to add motors. So I'm going to go to published parts, and in the drones, in the motors, I see there was a 6 kilowatt motor. So what I'm going to do is I'm going to kind of bring 4 of them in here, and now I have 4 motor parts out here, right? If I want to go, I can add them as 4 individual motors, left, right, north, south, and give it its own characteristics. But in this case, I just said I want 4 generic motors. Similarly, I can go to attributes and say, well, I really want to add additional attributes. Some of the attributes is called a flight time and a max load carrying capacity, right? So I can add those. If I don't like what's here, I can add a generic attribute. Let me add a generic attribute and give it whatever I want to kind of give its definition, right? So I can say generic attribute could be autonomous, autonomy, right? And I can give it a value, give it some characteristics and all the good stuff. Similarly, you can add your ports, you can add actions, state, constraint, requirements. You can add those that were published ahead of time, or you can add a generic one and modify it as you need it. Now, let's say in this case, for my small chassis, I have, if you go to the weapon carrying drone, so there's one chassis, let me add additional parts to it. So if you go to published parts, I go here, let's see, I'm going to add props. Let me use plastic props. Since there are 4 motors, let's say I need 16 of them. Each motor has 4 of them, so I'm going to add 16 of those. Similarly, I may decide to use other parts. I may have payload. I may have, now I could bring things from other packages. Till now I was working only in the drone package, but because other groups have published packages, I can bring things in. For example, if you look at the T800 Terminator 2, maybe they had some weapons that I could use, or they had some sensors that I could use. The idea is your organization can have these different life cycles, life cycle models of different components that they use, and they can be used to combine and build more and more complex systems out here. So a complex system I have is might be, you can see I have a Boston Dynamics humanoid 2024. It has some legs and it has a chassis. And the chassis itself expands into battery and leg and wheel parts. And each of them has their own subcomponents and hierarchy of what's going on inside. The beauty of this is you can always edit things. Like you can look at a part, you can look at your attachments, you can attach files to them, you can have collaboration, or you can look at a parts view. You can say, well, if I start at the top, let's say I'm looking at the human Boston Dynamics robot. I can click here. You can see it has two legs and it has a chassis, and each of the chassis has its own behavior, parts, and attributes. I can expand these and look at the individual component parts, and I can click on any of these cells and jump to that. Similarly, I can do more complex things like give me a parts view. You can see Boston Dynamics has basically two legs. This is a more tabular view of the parts, and it has a chassis. I can click on the chassis and kind of look at the parts view of the chassis itself. I can build a dynamic traceability report that tells me all the components and subcomponents and requirements that exist. I can get additional values that exist there. I can increase the depth of this. So this is a starting point of what the system can do. Now, the beauty of this is you can do your requirements management and traceability also here. You can define requirement types, you can define folders, you can define attributes, you can manage traceability, you can create traces. All the things that you can do in traditional TraceCloud, you can do them here. One other thing I want to highlight is if you go to tracecloud.com and if you go back to your project, Robots of Hollywood, you can always open the same project in the TraceCloud view. What it means is this project that you're looking at, the one with the um, structure built into it, where you have the model of your product, is actually exactly same as this product, this project. It is just that this is a different view of that problem. Over time, we plan to migrate a lot of this traditional TraceCloud functionality, like your dashboards, your status bars, your collaboration, approval workflow, import from Excel, generating complex report. All of this functionality will migrate to Darwin also, so you won't need to jump between two systems. But at the end of the day, it's the same core system. We just have a different representation of it. Um, you can always go to configure project to kind of configure your project, define your new requirement types. Within the requirement type, define new attributes. You can define roles for each role. You can define permissions. So all the traditional stuff you can do with TraceCloud, you can still do because it's the same underlying system, but you have more model-based system engineering capabilities that are rolled in. If you have questions, please reach out to support@tracecloud.com. We'll be happy to kind of help you, and you can help guide the product as it evolves. Thank you.